And next, I'll be introducing a talk on SciAuth, deploying interoperable and usable authorization tokens to enable scientific collaborations. This will be led by Jim Basney from University of Illinois at Urbana-Champaign, Brian Bockelman from Morgridge Institute for Research, and Derek Wetzel, University of Nebraska-Lincoln.
Thank you very much, Susan. Hi, everyone. And it's my pleasure to present our new SciAuth project to you today, along with Brian and Derek. As Rob mentioned this morning, SciAuth is one of the new projects out of the NSF CC program, and we're focused on deploying interoperable and usable authorization tokens to enable scientific collaborations. So why does the SciAuth project exist? There's a transformation underway in terms of authentication and authorization in NSF cyber infrastructure, from X509 user certificates to JSON Web Tokens. And in part, that's building on prior work from the SciTokens project that demonstrated the value of these types of authorization tokens. And so as part of that transformation, we want to, in the SciAuth project, help the community realize the security benefits of this new mechanism, apply the principle of least privilege, improve support for federated identities from InCommon. We'll be hearing more about the value of InCommon in a presentation later today by Brett and Rashna. Improve support for capability-based authorization and also attribute and role-based authorization, while reducing reliance on coarse-grained identity-based authorization, and moving us to a mechanism that's widely supported beyond just the cyber infrastructure community, but also being used in the broader web community. And so in part, we want to make sure that this transformation happens in a coordinated way so that we have interoperability across infrastructures. We pursue common approaches for usability and reliability for integration with science software and workflows, and we work together to improve the reliability and security of the infrastructure as we're making this transition. So next, Brian is going to talk to us more about the value of capability-based authorization.
Hey, everybody. I'm Brian Bockelman, the Morgridge Institute for Research. And I have a lovely 50-minute sales pitch about how we do authorization all wrong in distributed science. Unfortunately, Jim only gave me 10 minutes to talk. So I'm going to compress it a little, but certainly, hopefully, folks will have good questions for the end. So if we start way back at the beginning and try to think about what we mean by authorization, I apologize if I am speaking to the choir here, but if we start with some simple definition, I think of authorization as the process where you determine the access rights or privileges for a given resource. And in fact, this is something that we do every day. We might be at a cyber infrastructure or cyber security conference, but we do authorization just as much out in the real world, so to say. So my ID card gets me into my office building. My passport gets me into a new country, if we ever do get to travel again. A baseball ticket gets me to a baseball game, and then the Zoom URL got me into this particular meeting. And in fact, I like to mentally kind of think of this as a function. There's some authorization function out there that takes some number of inputs and returns a list of privileges or a set of privileges that the entity is allowed to do. And the process of putting together an authorization ecosystem is really all about defining that function and defining what sort of things go in terms of inputs. And where we get in trouble, however, is that we, in computing, I have really bad habit of mixing up the concept of authorization with one of the most popular models for making authorization, which is using authentication. All right, next slide. So in fact, you can have a number of different authorization schemes, some with or some without authentication. As I said, the authentication one is actually probably the most popular and at least the most recognizable one. That is, authentication will establish an identity for a remote entity. So you have a authentication function that takes some inputs. Usually this means username and password, although maybe this also means two-factor authentication right now. It gives you an identity that you establish for the remote entity, and then you have a list of authorized access rights. So this is how I get access to my Gmail login. When I'm using my ID card to get into my building, the ID card authenticates me to the door or to the elevator, and I am authorized to use the elevators. Similarly, maybe I'm trying to enter Switzerland. But again, there might be cases where we have authentication are not needed in the authorization system. So again, my baseball ticket is going to get me into a particular seat in the game, but my ticket doesn't actually say who I am. And similar to the webinar, although I claim to be Brian Bockelman from Mortgage Institute for Research, didn't actually authenticate me as that. One thing I'd like to point out, particularly in the cybersecurity crowd, that you can still have traceability through the system, which is a really important aspect of what we do, figuring out who did what action on a particular system. And you can have that attribute even if you don't use authentication for authorization itself. Next slide. So why do I care about this so passionately for distributed scientific computing? So I have a particular view of the world. Within OSG or when I work with CMS, try to take resources from all sorts of places, whether it's distributed clusters, whether they're cloud computing providers, or whether I find a laptop under a rock. I take all these resources on behalf of some organization, put them together in the central pool, and present that pool of resources as a usable entity for individuals. And in that case, the resource provider has a relationship with the organization, not the individual. Actually, a more the easier way of thinking about this is often how we will present AWS resources. Hopefully, all of us know better than going off and giving 1,000 scientists 1,000 credit cards to go purchase from AWS. Instead, what we most likely end up with is somebody in the collaboration, scientific collaboration, interacts with AWS, and then makes decisions about resource allocation out to the end users. And here, of course, AWS recognizes the person with the credit card who's representing the collaboration. This is used in Exceed when we do community accounts. And of course, I often like to point out that not everybody interacts with organizations. And a good counterexample is traditional Exceed extract allocations, where the user does get an individual account and get to be known by the scientific resource. So when I think of distributed scientific computing, I think of this side of the world where we're trying to gather resources and interact with resource providers. Next slide. So historically, particularly in the OSG and WLCG, we did this by establishing some sort of global identity. As Jim mentioned, we use X509 certificates. The site established an identity mapping, usually to some sort of local Unix account. And then based on what that Unix account was allowed to do, the client was authorized for any of those privileges. So this is particularly problematic in two ways. One, there's not fine-grained authorization. This basically gives you your traveling power of attorney that goes to every remote host on the planet. And then also it's wrong because the resource, again, doesn't have a relationship with the user. The authorization decisions about resource allocation really belongs to the organization who wants to then to delegate decisions down at that resource. Next slide. So what we ended up working with is capabilities as opposed to having an identity-centric world. So a capability we think of as a token or entity that authorizes a particular action on the object. So for example, my favorite is the house key. You can give that house key to anybody and they can open a particular door. And you don't actually establish an identity. And this turns the conversation to, what are you permitted to do as opposed to who you are. So within our community, we've built on top of the standard JWT profile and built a agreed upon way to distribute, to allow distributed token verification and agreed upon set of capabilities. So on the right is a little snapshot of the tokens that we use. The top is what the raw base64 encoded form, and the bottom are the different attributes of the token. And all these attributes either identify some part of the token, such as who issued it, or who the subject was, or some sort of limitation, such as when does it expire, or when does, or what are the permitted activities. Next slide. So each of these tokens has an issuer, which maps to our scientific organization. And that issuer then generates these fine-grained capabilities. So the capabilities are evaluated with respect to the issuer's authorization. And the remote resources don't really need to know the individual users. They just need to understand what scientific organizations they support. And particularly for file access, we are able to go very fine-grained and able to go down to individual file authorization, as opposed to trying to do this with identities. So in the sample token, decoded token on the left, this is issued from one of our test issuers for the WLCG. Within the token are the capabilities to do storage, read, and modify. And that implies that anybody who holds this token has the ability to read or write within the issuer's namespace at the particular storage endpoint. Next slide.
Thanks, Brian. And so as Brian mentioned, this capabilities-based authorization approach builds on work in SciTokens and with OAuth and JWT standards, and that they give us the possibility of doing more fine-grained access control, implementing the principle of least privilege. So you can visit the SciTokens website for specifications, publications associated with that project, and multiple open source implementations are available on GitHub, building on those standard OAuth and JWT libraries. Brian also mentioned the value of building on standards. So here's a list of the standards that SciTokens builds on, the primarily OAuth 2 standards and the JSON Web Token standard. And in particular, this forthcoming RFC JSON Web Token profile for OAuth 2 access tokens is really key to bringing these two things together, OAuth with JWTs. And Brian included that reference to this DOI, the WLCG Common JWT Profile specification, which is really key for explaining how to use these tokens in our scientific cyber infrastructure. And so this specification covers 3 use cases: identity tokens with groups, access tokens with groups, and access tokens with authorization scopes. And in particular, the SciTokens project was focused on that third case, using authorization scopes to implement capabilities. So building on that prior SciTokens work, our goal in the SciAuth project is to bring these capabilities together, bring these technologies together, and work with the different science projects. So WLCG has an active authorization working group that we participate in. LIGO now has a SciTokens implementation working group, and we're working with Fermilab and Exceed and others to coordinate on the migration and deployment of the JWT authorization-based approach. This involves collaborations with different security groups like InCommon, like Tag PMA and Refeds, and integration with important pieces of scientific software like HT Condor and Jupyter, and also providing training and documentation and and demonstrations, and also some workforce development through a fellowship program. So we see the timeline that we're in the middle of in this migration to JSON Web Token approach. Way back in January 2018, the Globus Toolkit end of support for X509 user certificates was announced, and the SciTokens project began our work integrating this new, this alternative to using X509 user certificates. We had the WLCG profile published, integration with XRootD and HT Condor and others. And so now we're in this transition period. The SciTokens project has completed its work, and we're starting the SciAuth project, working with LIGO, working with OSG, that is preparing to retire the Globus security infrastructure using X509 user certificates. And then WLCG also has retiring X509 user certificates on their roadmap as well. And so connecting up with the roadmaps of the different infrastructures is really key to making sure that we maintain interoperability across infrastructures and we can benefit from each other's work. And so I mentioned that coordination, outreach, training are really key activities for SciAuth. We have security is another important area of activity for us, providing software demonstrations and integrations, helping with the development of more profiles and interoperability across these standards-based implementations, and building the workforce around distributed authorization. So in particular, in the security area, threat modeling is important for us, providing operational guidelines, doing assessments of implementations, doing peer reviews of the token issuers in the environment, and also running some tabletop exercises are some of the activities we plan to perform in the SciAuth project. So the key thing about SciAuth is we're about supporting the community's transition to this new technology, this new approach, not about developing new software capabilities. SciTokens and others have developed software, have developed the capability, and now it's about doing the hard work to deploy it, to operate it in a usable, secure, interoperable, reliable way. So I mentioned threat modeling as being a real key activity for us. And so the Trusted CI Open Science Cyber Risk Profile is an important methodology for doing threat modeling. And so we think about the impacts of credential exposure, too much scope in a token that's being sent out on the infrastructure, a token being obtained by a malicious client. This could be a client that's a service distributed in the infrastructure, and this could result in lost data, corrupted data, exposed data that has impacts like reputation loss that we heard from in the panel this morning, bad science results, loss of non-reproducible data, like the example that Vaughn gave, where if you have data about some natural observation, you only get that observation once. And so these are some of the threats and impacts that we've been thinking about in the SciAuth project. And then we've been looking at the different mitigations that these standards provide for addressing these threats. So credential exposure can be addressed through short lifetimes on tokens, encrypted transit, protecting the refresh tokens on only trusted components of the distributed architecture, having the ability to revoke tokens. Granting too much access is addressed by least privilege, and also especially supporting token exchange, so that as your workflow is running across the infrastructure, you can drop privileges in your token and not carry that power of attorney with you everywhere that Brian talked about. Addressing malicious clients by being able to vet clients, revoke clients, have policies about tokens applied to particular clients. And then we think about other threats like compromise of the token issuer. And we need the ability to revoke the signing key of a token issuer and get that revocation event distributed quickly through the system. And so other references for us besides OSCRP are the OAuth 2 threat model and JSON Web Token best current practices. And so now that brings me to our demo portion of the presentation. So if you'd like to follow along, you can visit this URL, sciauth.org/notebook-demo. And I believe Brian Bachman's going to, I believe Derek Weitzel is going to take over the screen and give us a live demo today.
That's right. So if you want to follow along, please go ahead and put that in your browser. It's also available in the talk. So now I'm going to just quickly go over the demo, and I want to point out a few things that this demo is showing. In this demo, you'll learn how to request a demo credential from the SciTokens issuer, examine a token, how to validate a token, and a bonus exercise where you can earn an open badge. But this demo is most likely to give an idea of what it's like to develop with SciTokens. Like all Python, you first have to import the library. Now, the first thing we want to do is be able to get a token. So in order to get a token, you have to contact an issuer, and they have to create a token and sign it with a private key and return it to you. And so we have a demo issuer, demo.SciTokens, that will issue any token that you want. And so even that's great for testing, but no production site should ever enable the demo SciTokens issuer because anybody can get tokens that say anything. And so this function all does is just request a token. And here I'm going to put in my email address in this subject line. And we request the token, and it just returns this JWT. Now, JWTs are base 64 encoded of JSON. And in order to parse the token, we can use the SciTokens library to deserialize it. So I'm just going to grab the token once again, and then deserialize it. So we take the raw token, and then the audience, and remember, deserialization happens usually on servers. So the server knows who they are themselves. And so the server puts in the audience that it's expecting, which is the demo.SciTokens. And then we can print out all the claims in the token it returned to me. So you'll see it has this email subject is the first attribute. Version is the profile that we're using for this token. We're using the SciToken 2.0 profile. The other profiles that are available are SciTokens 1.0, and then the WLCG also has their own profile. They're all JSON web tokens, but they all have a little bit differences in behavior and validation step mostly. You'll see that the audience is what we expected, demo.SciTokens, issuer, expiration, EXP. These are all Unix epoch times, and then semi-random JSON token ID number. So what happens if you edit the token? Let's say a malicious actor somehow gets between you and the issuer and edits the token before it returns to you. What happens is the SciTokens library will parse it and it will check that the signature, which is the last bit of the JSON web token, does not match the public key using the public key is expecting, and so it'll throw this big long error. And you also cannot edit a token and then serialize it with the same issuer because you don't have the key. You don't have the private key for the issuer. So this is something that serializing a token is something that an issuer would do. It's not something that a user would do. And of course, you can request a new updated token from the demo issuer, and I'm going to enter my email address once again. And we can do get the token using that method. Now I see I went a little fast, so I might actually have time to talk real briefly about how to verify a token against authorization. Now this is just the Python implementation. And so the SciToken C++ library implements this very similarly. So we'll first grab the token and deserialize it. And then we create an enforcer. And so this enforcer, basically you're able to query the token. Do you have access to these various attributes? And so you'll see up here in the scope, we did read of /protected. And so this first thing, we would expect this one to work. The enforcer test with this parse token, you're querying the token, can it read from /protected? And that should be true. Now, can it read from some other path that is not in the scope? That should be false. Can it read a file that's underneath the protected? Yes. Even quite a way down the directory path? Yes. And the scope specifies just the beginning of the path that's available. Anything under that is assumed to be also follow the same. Now, the scope said read protected. Can you write to it? And you would expect that to be false, and that's true. And this demo goes on to show how to query an HTTP over HTTP using the authorization header. This is how you query with bearer tokens. And I give it a curl example. And then finally an exercise at the end where you're able to query the demo issuer, and then it will issue you an open badge. That's my demo. Thank you.
Thanks, Derek. I'm going to take the screen back and wrap us up and leave a good amount of time for questions. So please, I think we've got one question so far, and I hope we get more. Would you like to learn more about this topic? I invite you, if you haven't already, to view the recordings from recent Trusted CI webinars. In January, we had a SciTokens webinar, and then in July, a webinar that Brian Bockelman did focused about the application of capability-based authorization to Open Science Grid. And we have two exciting upcoming events in the next few days. So Thursday and Friday this week, OSG is holding a token transition workshop. And then on Monday, we have a summit workshop on token-based authentication and authorization. So I hope many of you will join us for those events. We are also accepting applications for our SciAuth Student Fellows program. So if you're a student interested in this topic, enrolled in a US higher education institution, I definitely encourage you to apply. The program includes a $1,000 stipend. If you know students who might be interested, please send them our way. Check out sciauth.org/fellows for more details. And that wraps up our presentation. So Susan, I think we have, well, let me just say, visit sciauth.org for more info, send us email anytime. If you have questions or comments, we'll also be in Slack, but I think we have time for some live questions now.